Okay, we'll be looking at inverse trig ratios today. So let's get the little doggies out of here and bring in the big dog. Huskies, UW. Okay, quick reminder, SOHCAHTOA is always our friend. It reminds me that sine is opposite over hypotenuse, that cosine is adjacent over hypotenuse, and tangent has to be opposite over adjacent. So for the inverse trig functions, or the inverse trig ratios, again, I got to have a right triangle. I got to be looking at one of the acute angles. So for the inverse tangent, I actually start with the ratio, and the inverse will get me the angle. All right? We're used to going the other way. We are used to having the angle, and we ask for the tangent of that angle, or the sine of that angle, or the cosine of that angle. Instead, we'll say, hey, we got the ratio. Let's go backwards. Can you tell me what angle made that ratio? And the first thing we really need to talk about is what on earth is that -1 trying to tell us, right? That -1 is not an exponent, right? So let's take a look at cosine and try to figure out exactly what that -1 is telling me, right? It tells me that it's an inverse function, not a reciprocal. If it was a plain old number, the -1 would be an exponent. But instead, when it's a function, that -1 tells me inverse function. So cosine with that -1 is telling me I want the arc cosine. If I did want the reciprocal, 1 over cosine of x, that would be secant of x, right? The reciprocal of cosine is secant. That's not what we're talking about with that -1. With that -1, we're talking about the arc cosine. Sometimes I might say inverse cosine, sometimes I might say arc cosine. They mean the same thing. Okay, so without touching a calculator, let's see if we can figure out a few values here. Let's start in the traditional direction. Let's start with cosine of 60 degrees. Well, no choice. I have to pick a 60-degree angle. And SOHCAHTOA reminds me that I need adjacent over hypotenuse. So cosine of 60 degrees has to be 1/2. Now, what if I want to go backward? What if I want an arc cosine of √3/2? Okay, so I have the ratio. I want to know what angle made this ratio. Well, if √3 is the adjacent and 2 is the hypotenuse, I must be at the 30-degree angle, right? Because √3 had to be adjacent. So the arc cosine of √3/2 is 30 degrees. Tangent of 45 degrees. Well, let's go stand at a 45-degree angle. Opposite is 1. Adjacent is 1. Tangent is opposite over adjacent, so I've got 1 over 1. Of course, 1 over 1 simplifies to be 1. Okay, let's try an example of tangent going the opposite direction. Let's do arc tangent of √3. Wait a minute, I need a ratio. Let's rewrite √3 as √3/1. Now, tangent is opposite over adjacent, so √3 has to be the opposite leg. So if √3 is opposite, and 1 is adjacent, I must be at the 60-degree angle. Arc tangent of root 3 is 60 degrees. Well, we did cosine, we did tangent. Let's do sine. Sine of 45 degrees. Pick a 45-degree angle. Sine is opposite over hypotenuse. 1 over square root of 2. Huh. Radical denominator. Not. We can't leave square root in the bottom of a fraction. Multiply by the number 1, but disguise the number 1 as root 2 over root 2. Remember, I can always multiply by the number 1 and not change the value. That's why we're allowed to do that. And, of course, we come up with root 2 over 2. Arc sine of 1/2. Let's go the opposite direction. Now, I got to be careful because there's a bunch of 1s, right? I've got 2 different triangles, and I see 1s on both of them. So instead, I'm going to focus on the hypotenuse. The hypotenuse has to be 2. Opposite has to be 1. So I'm in the 30-degree angle, right? Opposite over hypotenuse is 1 over 2. It's got to be the 30-degree angle. Find the sine of theta if arc cosine of 6/7 equals theta. Well, boy, I don't even know where to get started. What do I do? If you don't see a picture, draw a right triangle. Okay, so cosine is adjacent over hypotenuse. So inverse cosine of adjacent over hypotenuse has to equal theta. So 6 is my adjacent side. 7 is my hypotenuse. And so now I can go find sine, right? Sine is opposite over hypotenuse. And of course the opposite, what is the opposite leg? Well, Pythagorean theorem is going to come to my rescue. Got to find that missing side. Of course, 6 times 6 is 36. 7 times 7 is 49. Subtract 36 from each side of the equation. Notice I'm showing the subtraction horizontally instead of vertically, just for a change of pace. 13, that seems kind of big. Oh, forgot to take the square root. There's the shorter leg. I'm sorry, not shorter leg, the opposite leg. Opposite of our angle is root 13, right? Sine is opposite over hypotenuse. Root 13 over 7. Again, I'm not worried about the shape of that triangle, right? That side labeled 6 versus that side labeled 7 versus that side labeled square root of 13, right? It's not in the correct proportions, right? Square root of 13 is about 3 point something, but it looks like it's as big as the side labeled 6. Don't worry about that. We've got our answer, root 13 over 7. And again, I'm going to have the exact same triangle. I'm not going to worry about whether or not I've got it proportionally correct. And of course, sine is opposite over hypotenuse. So if I've got arc sine, again, I'm dealing with opposite over hypotenuse. So that 2 root 2 has to be my opposite side. That 3 has to be my hypotenuse. And of course, if I want tangent, I have to do opposite over adjacent. let's find the adjacent side. Pythagorean theorem. Hypotenuse is 3. That 2 root 2 I can put in as A or B, does not matter. 3 squared is easy, that's 9, but the 2 root 2 quantity squared, that's a little bit trickier to figure out. Subtract 8 from each side. Again, I'll do it horizontally for change of pace. And of course, the square root of 1 is just going to be 1. There's my adjacent side. So tangent is opposite over adjacent. Oh, that simplifies nicely. That's just going to be 2 root 2. Whew. Again, only a worksheet today. We just have maybe not gotten quite so far as I would have liked this school year, and the IXL is a little bit more advanced than what we're doing here with the trigonometry. So it'll just be a worksheet today.
Well.